Okay, so this time they don't give it to us in that form that we're used to seeing. Now you'll notice you have x squared. That's important. So we're looking for some kind of form like this. They call it standard form. I don't know, I think I could argue on that, but you can't call everything standard form. But for our purposes with what we're doing, we want it in that form. So what you're going to do is you're going to keep the x terms on the left. And that's just because it's x squared. If it had been y squared, you'd keep the y terms on the left. And then we're going to take these other two terms to the other side. So leave a little space, 28y plus 208. Okay, then we're going to complete the squares. So you take -8, half of that is -4, square it, and you get 16. So you add 16 to both sides because you want to complete the square. So now you have x minus 4 squared equals 28y plus 224. Okay, so we're almost in that form, but we really want this 4p out there. So what we're going to do is we're going to factor out the greatest common factor. And in this case, it is 28. You'd have to make sure that that y was 1y. So whatever the coefficient is on y. But it's 28. Goes in evenly, so you get this. Okay, now that tells us then a couple things. H is 4, K is -8, so the H is coming from here, the K is coming from here, and then we know that 28 equals 4p. Sorry to write backwards. 4p equals 28. That's coming from right there. So divide both sides by 4, p equals 7. And then what we can do is we can just figure everything out. The vertex, so use your note page, is h comma k. So our vertex is going to be 4, -8. And then, let's see, we have to do the axis of symmetry. And we know we're going to have a right side up parabola. It's going to be like this. So the axis of symmetry is going to go through that vertex. So it's going to be x equals h. And so for us, our axis of symmetry is going to be x equals 4. And what else do we want to know? The focus. Okay. So the focus, let's see, that's going to be at, let's see, I have to go over to where the vertex is, so H, and then it's going to be K plus P. So for us, our vertex, or our focus is going to be 4, and then I've got to go K, which, what was K? -8 plus P. So I get -1. Okay, -8 plus 7. That's where that's coming from. Okay, so we've got that. Now we need the directrix. See, I don't usually do it this way. I usually just graph it and then come up with the information. But I thought, well, I'll do it a different way this time. You might like this way better. Okay, so the directrix, remember we had a right side up parabola. So the directrix has to be like down here somewhere. That distance has to be p, -p. So it's still going to be in line with the focus, but the directrix is going to be y equals k minus p. And for us, that's going to be y equals, our k is what, -8 minus 7. So the directrix is going to be at -15. This is going to be kind of a big parabola, so I think we're going to have to count by 2's on our grid. Okay, we did the directrix and the endpoints. Oops. The endpoints of the lattice rectum. And you can find all of those formulas on our little page of notes that we had. So the endpoints are going to be h plus or minus 2p comma, k plus p. Now we know everything from right up here. We know what h, k, and p are. So we can just put those in. And we're going to get, our h was what? 4 plus, I'm supposed to be doing this in orange. 4 plus or minus 2 times p was 7. And then our k was negative 8 plus p, which was 7. Okay, now that's going to give us 2 points. We're going to have 4 plus 14, comma, negative 1, or 18, comma, negative 1. And the other one's going to be, I usually do the minus first, but it's going to be 4 minus 14, comma, negative 1, which is going to be negative 10, comma, negative 1. Okay, so we're going to count by 2's. So we're going to make this, let's see, 2, 4, 6, 8, 10, and 20, and then negative 10 and negative 20. Okay, and then 10, 2, 4, 6, 8, 10, and 20, and go a little bit further, negative 10 and negative 20, just so we can fit it on there because our numbers are big. Okay, now we need all that information that I kind of scrolled off, but we'll see if I can just do this from memory here. Okay, so I think I've got it. The vertex was at 4, negative 8. Okay, so vertex, I'll just rewrite it, 4, negative 8. Okay, so let's graph that. So 4, negative 8 is going to be right there. There's my vertex. And then do we want to graph the axis of symmetry? The axis of symmetry has to go through there. So it's going to go right through there. And the axis of symmetry was x equals 4. Okay. And then what else did we want? The directrix. The directrix, D for directrix, is going to be, let's see. Oh, it was x equals negative 15. You probably have this all in front of you. Okay, so negative 15, the directrix is going to be right through there. Okay. And then, do we just need the endpoints? The endpoints, we have those. They were at negative 10, negative 1, and 18, negative 1. So, let's see. Oh, I didn't graph the focus. I forgot. I left out the focus. Sorry. Let's put the focus in real quick. I'm going to write it down here. The focus was 4, negative 1. So 4, negative 1. It's going to be like right there. And then those endpoints. So negative 10, negative 1 is going to be like right there because I'm counting by 2's. And then 18, negative 1 is going to be like there. So we'll just try to draw a parabola. Okay. Yeah, it's kind of hard sometimes with the bigger ones. But anyway, there we go. It's all graphed, labeled. We found everything. Those are the long kind where you have to get it into the form first.